All right, now in our previous exercise, I teach you how to use on delay timer and off delay timer, when to use any of them, okay? So I want to use automation software to also illustrate the function and its reality between the two timers. Now, this is on delay timer, okay? Let me get you the logic. Now, this is the logic. So let's reduce the logic. I want you to relate the two, uh, just hold on. Okay, now let's put the logic this way. All right, now take a look. Like I told you, now before feeding this particular timer, you can see that I feed the timer from the contact. From the logic now, take a look at the logic. Before feeding the timer, I come from the logic here down. Before feeding the timer, I feed both of them simultaneously, feed. So the same way, look at this lashing circuit. This is my lashing circuit. So from my lashing circuit, I have a branch that feed this timer. The same way, from this my lashing circuit, I have a branch here to feed the coil. This is my schematic control, and this is my automation control, automation program. Now, I want to show you difference between them. Now, if I want to simulate this, let's do that. Let's simulate. Uh, Remember, this is on delay and this is on delay. So drop this, let's simulate. I want to simulate now. All right, now let's put on this. I want to put on this pump. This pump will now start running. After the preset time, let's increase the time. Let's increase the time to perhaps 5 seconds. Okay. Remember that the subject is that I want to teach you when to use on delay and when to use off delay. Okay. All right. Put it on. Sorry, we need to compile. After changing, we compile. Okay. Now let's put it on. I want to put on the pump using my bit 4. My pump is on now. Now the time is counting. The timer is counting. Look at it. It now cut off after 5 seconds. Cut off my pump. Now, same does not apply for off delay timer. Let me change this to off delay timer. This is my off delay timer. Okay. Now, let's test again. Let's simulate. Okay. Want to put on the pump. Watch. The pump is not on. The pump didn't come. I on again. Look at it. Remember I told you that. Remember I told you that the off delay timer, the off delay timer, we have to change state. This off delay timer have to change state 2 times. So in that case, once I energize this, here will open. The first state that will change is that this contact will change state. So upon energizing this, here will open. And once here open, I don't have power to my pump any longer. And the objective is that I want the pump to come up first, then shut down after the time of this elapse. Now let's change it again. Let's change it to NO. Okay, just watch. I want you to know when to use off delay and on delay. All right. You see that you will still have problem. You still have issue. Okay. So let's put it on. All right. We put on the system. Look at it. The pump is running. and off delay refused to count because I still have steady power to the timer. Like I told you, you must cut off power from the coil before this one will count, before the counting time will start. So the logic is not working. So in that case, we have to change the logic. Like I told you, take a look at this. This one didn't work in our logic, in our control. This one did not work. It's only this one that passed test. This one didn't work because this logic is not for off delay. This particular logic is not for off delay. This logic is for only for on delay. So if I want to relate this to my PLC software, the same way I can't use this circuit to feed my off delay. So you must introduce another logic in another network. The same way, take a look at this. Look at this. This my logic here is my lashing logic. So I cannot energize my off delay within this network, within this logic. You must have a different branch circuit. That is what I have here. This is a branch logic, not within this logic. So you can't feed this from here. You must generate another circuit to feed this. So this is what I'm going to do here now. So how can we do that? We're going to delete this. We don't need it here. So we're going to insert that in another network. So leave this slashing logic and leave the contact here. Okay, leave the contact here. So come to another network and insert that particular off delay. Come here and insert the T1 or T2. Just pay attention. Let's say 5 seconds. Okay, now you remember that here I have to now introduce a signal source to my timer. Where is my signal source? I don't want to use pump. I will use this start so that upon starting this, that is the same way this one will start immediately. Once the starting command is initiated, it's also initiated this. This one also be initiated. The reason is this. When I start the process, I want to use momentary switch, and that momentary switch is passing signal here, and this one will lash. Once this one perform the function of passing signal, is no longer needed. It will go back. That same time, simultaneously, it also pass instruction here and also go back because it's a momentary signal. The instruction is a momentary instruction. So just send the signal and go back to your original state. That is what this one does. So because of that, I no longer need this because I need this one on different functions. So I will now insert this and copy this. I need this same command. I need a command of initiation. So that start command that I need here for the pump to commence work is what that same start command is what I need. But in this time, just send the instruction and go back. And this one start counting. I don't need to lash it. If I lash it, it will not count. Okay? So if that is done, so let's now control the pump using this command. Okay? So let's download it. Okay, now let's monitor. All right, I want to put on this pump now. I put it on. Momentarily, look at the pump running. Look at it, my stop off delay timer counting. Okay, let's increase the time. Let's say 10 seconds. So that you'll be able to monitor the process. Sorry, need to compile and download. Now, I'll put on this pump. The pump will lash here and remain on. It will cut off here. Take a look. You now understand that The previous on delay timer I use normally open and I use normally close here. But this time I use normally open because this one will change state immediately I energize this coil. Here will close immediately. The same way with my control logic. Look at it. Look at the logic. Here is open. Here is open. This contact is open belonging to this. Upon this one closing, this one also close. The power comes in here. Here will close immediately. Same power here. Then the second time this will change state again is after this one has finished counting. Here will open. You see that this one is normally open. The same way here is normally open. Okay. Here will close immediately when here get energized, and that is the same time this one will get energized. This logic, this lashing logic. Okay. So let's simulate again. I put the system on. I release my hand. Here remain maintained. Lash here and the pump is working and the time is counting. Meanwhile, here is de-energized. The signal is de-energized, but it's still counting. You see, the time has completed and here will get cut off and the entire system shut down. Let's simulate again. It's now counting. The pump is running. Here is counting, but the signal is cut off, just like here cut off. But I have here lashed, but this one is still counting because it's off delay timer. Off delay timer is that it has to shut down before counting. All right. So this is how to when to use off delay timer and when to use on delay timer. Okay. And if I change the logic, if I change this, just watch. If I change this to on delay, the system will not work. Let's simulate so that you get. Sorry, you need to compile and download. So let's put it on. Now see that the pump cannot on because here is not closed. So let me change it. Okay, the system will not still work because the logic will not be the same. Now, when I energize this, I get to release my hand for the switch to bounce back. And if that is done here, here will stop working. This particular coil need a steady pulse, for the contact to change state. If the supply to the coil is not being maintained, the contact will not change state. So in that case, the logic for on delay and logic for off delay is never the same. So that is what I want to, the information I want you to understand. So come back to this control. Take a look at this. This logic is completely different from this logic. Okay, so this is the logic for off delay and this is logic for on delay. And not just for on delay, this logic is for on delay, but when you want to use the on delay for off delay function, that is when you use this. Okay, all right, thank you. um let's go back to our control. Let me just make one thing clear again one more time. Now we are back here again. This is our previous exercise. Okay, now let's put up let's try and put up an indicator lamp so that you appreciate the simulation more better. Okay, let's put up indicator lamp. um I need an indicator lamp to signal when this one is in a close, when the pump is working. So we're going to do that for this as well. Shut down this. We no longer need okay, just hold on. So we need an indicator lamp to give us signal. um we need a lamp, Need a lamp here. Okay, we can as well use 3D lamp. Let's see if we can use 3D lamp. Okay, okay, can go back a bit. I want this one to be red. Okay, okay, now this one is our K1. So the contact should bear the same tag, all right? When K1 closes, this one will get activated. This is K3. So the contact should bear K3. Okay. When this one closes, here will also close. I will have power here. Okay. So let's do that. Let's simulate once more. I want to put on this pump, this particular pump. I put it on like this. The pump is running. Here is on. When the time is completed, look at it shutting down. So this one has shut down. I want to put on this. This one is on. It's now counting. When time is complete, it shut down. Okay, so this is how to use on delay timer and off delay timer. So understand when to use the two. So this logic is not useful now. This one is useless. I use it to illustrate these two because they are two, they are identical logic. They are the same logic, but don't use the same timer for the two logic. So on delay timer logic and off delay timer logic, they are never the same. There is a difference between the two. So that is what I want to bring to your notice. So don't use the logic of on delay timer and off delay timer as one. Okay. Now, in terms of hardware replacement, we want to do hardware replacement, and you discover that this logic, this timer is on delay timer. So don't go and purchase off delay timer because it will not give you the same function. That's what I'm trying. That is a summary of what I'm telling you about. Okay. So if a logic is designed and you want to make a replacement and you discover that the hardware timer is of off delay function, you must replace that particular timer for off delay function. If you want to use a different relay for the same logic, you will have an issue. So you have to change some connections. You have to change the connection process. If you want to maintain the logic connection by swapping the two, it will not go. All right, it will not have the same function. The function, the logic for off delay timer, this is how you're going to represent it. Then logic for on delay timer, this is how you're going to put it. Okay, I repeat again, the logic for off delay timer to function as off, for on delay timer to function like off delay timer. This is what you need. Okay, because if you are understanding it that logic for on delay timer must be this, no, this is not complete way of doing. This is not the only way of doing a logic for on delay. We have multiple ways. We have more than 10 different ways of putting up a logic for on delay timer. We have more than 10 ways of doing that. But if you want it to react as off delay timer, this is what you do. This is the way you represent it. Okay, you will feed the timer. You're going to feed the timer through the contact. Why you're going to feed the timer through the contact is because when the contact change state, the power will disconnect from here immediately. And this other one that is in charge of retaining lashing circuit will also get disconnected. So once this one is disconnected, the entire system will shut down. So if you are feeding on delay timer from lashing circuit, so the result is that when the timing is elapsed, the entire system will shut down. Okay. Okay. Now, but if you are feeding, let's see if we can change this. If you are feeding this one from another source, if you are feeding this from another source, supposing I'm feeding this from here, let me feed it from here. Supposing I'm feeding that timer from no, it shouldn't be from there. Supposing I'm feeding this timer from a different, maybe I have another relay. Supposing I have another relay, um, supposing I have another relay here. Okay, let's extend this power. Let's just quickly change this. I want to show you something. I have another relay here that is arrow 1. This relay is arrow 1. Okay, and this relay is activated this way. This is the relay responsible for my lashing circuit, no longer contactor. Take note, I want to edit this. This time it's going to shut down my pump, but it's not acting as a cool down direction. It's not acting as my off delay timer. It's now acting as normal on delay timer. It's not now, it's the function is not of, it's not doing the function of off delay timer. It's doing the function of normal on delay timer. Okay, so let me give you on delay normal timer circuit. So I have a relay here. It's an integral part of this. So the relay will get energized to take control of my lashing circuit. No longer contactor. Contactor is no longer responsible for lashing function. It's going to take over by this relay. Okay, so this relay is now responsible for my lashing function. Then the function of this contactor is going to be replaced by this timer. Timer is going to control the pump differently. So watch. Take this. So now I feed this to maintain my lashing circuit to this. Okay. Now watch this circuit now. My lashing function is now taken over by this relay. No longer this. But this will cut down, will shut down by this T1. T1 will shut it down, but power will still be maintained to my coil of the timer. Let's do the simulation, okay? I put on the system. Sorry. Yes, I put on the system. The contactor is working. My load is on. Look at it. The pump is shut down. Look at the lamp on, off. The pump has shut down. But I still have my power maintained to my coil. That is what I'm saying. I still have my on delay timer energized, but the primary objective is accomplished. The objective is that I want the pump to shut down after preset time, and that is done now. But I still have my power maintained to my contact, to my coil. I still have my power also to my relay. So in that case, these two devices is still taking my energy. My energy for my circuit is still being used, being utilized by these two devices. But in the case of this, watch how this one shut down the pump and also shut down the entire system. Just watch. I put on the system, the pump is running, my off delay is counting. Now the system shut down, the entire cycle shut down completely. So now the entire plant, I can put on the plant to pump water into 1 million liter volume of tank. And I can sit down in my control room watching the tank feed up before close of work. So I can put on the system and also shut down the system immediately and leave the plant. When the tank is filled up and that particular time is set to feed the tank up, it will shut down. The system, the entire plant will shut down for me. It will shut down on my behalf. So that is the advantage of using off delay timer to control a process. But in the case of this, I put on the system will shut down after a preset time, but this logic will still maintain power. You see the difference between on delay and off delay. All right. So this is how to use the on delay and off delay timer. Okay. Now, but supposing I want to use the off delay to do the function of, an on delay to use the function of off delay. So that is the logic I will do. I will do the original logic, take away this relay. Okay. I'll take away this. I'll now use the original logic that we did the first time. All right. So I'll now take away this. Take away this. And now feed this. Then I will change the logic. Sorry. So this is what I will do. Then this one will now be K1. So the lashing function will be taken over by contactor, no longer additional relay. So in that case, this logic will now shut down the system and also shut down the pump. It will now do the function of this off delay time. Okay. All right. So this is the information I bring to you. So what you need to do is to also subscribe to my channel so that subsequent edition and subsequent segment will also come to you. If you don't subscribe and you don't like, Facebook no longer bring the other exercise that's related to this, because the only way you tell Facebook that this particular information is of higher relevance to me is by subscription. Subscribe, just click subscribe and also share and also comment. You must do any of these three things. Either you like, or you comment, or you share. That is a way to tell Facebook that I need the information, I need this information or related information such as this. And that is the only way to also tell me that you need this so that subsequent edition will also be pushed across to you. Okay. All right. Thank you.